Alright, so today I'm doing the seam carving homework. And seam carving is a resizing technique to resize the image. So let's use the images over here as the example. We are given the image on the left as original image, and calling the API of the class seam carving we're going to implement in this class. If you output the right image or the image on the right part, so yeah, it looks pretty good. This algorithm or technique doesn't make the image or make the object that looks weird. So you probably have this experience when using the scaling or cropping technique. It kind of make the image weird or lose some really important information from the image. But same carving really, solve the problem prettily or beautifully. So it still preserve the most important information in the original image. For example, we have, the people skating over here, the mountain, uh, clouds, so all looks good, looks as natural. So yeah, so I just made a slides for that overview of this homework. Hopefully it will be helpful for you to see that, boost up what you are doing. Here's the presentation, same carving. And by finishing or implementing same carving, you need to read through the homework page and FAQ page. FAQ page I figured out is really helpful, especially the bottom of the page. It gives you the detail and instructions about how to implement the homework or the class steps by steps. Is a really really good reference. And the second, also I will uh, talk a little bit about that in the next slides or next couple slides. And second, be familiar with the picture, the Java and how it works, because in the homework page, it doesn't really explain a lot, but you will use later in the homework. And third is the main point of this homework, because we need to do the shortest path algorithm to to support the same carving technique. So to implement the shortest path algorithm, we need a dist2 and edge2. If you watch the videos, you should be able or be good to go. So yeah, so basically, these two is just tell you the distance between the source point and your index, like two other points, and edge two is just the last edge to this point. Okay, and let's move on. So here's the steps. It's just the detailed steps from the FAQ pages, and it's really helpful if you are thinking this homework is crazy and you don't know where you should start. That is the right place you need to go. So this homework we just implement the Java class, the API, and we should start from an easy function. They are easy to implement. For example, a picture, a width, height. They are very simple. And the next one is the energy function. This are getting complicated, but the homework did a good job, explained a lot about that. And energy basically is just in the images means the importance of this pixel. Should we keep it or include in the seam, which is like garbage information over there? And we can all tell about this stuff. And next we should be able to find the vertical seam. We remove that. And pretty much about that. And hard part, definitely find the vertical, the step 3, and find the horizontal and remove them. And also for this homework, it's kind of hard to do the optimization. It's interesting to do that. We'll talk a little bit about it later. Okay. So, as I mentioned before, the energy function is just uh, the value of the importance of this pixel. So we check here, we have the energies function over here. By the way, this is a 4x3 images, 3x4 images, and is calculate or is use the method mentioned from the homework page, just a math formula, and yeah, we should be able to compute that. Won't be hard. And when we do the energy function, there's a question about that is should we store the energy of each pixel into a global variable or just a temporary variable? Yeah, that's the point to optimize our codes, make it more efficient, and we'll talk about it later. So here we have the find same. In the API, we have two functions. One is find vertical, another is find horizontal. And if you know how to implement one of them, you should be able to do another one. You can either, do the similar stuff, swap X, Y, or you transpose the image. Transpose is a kind of like the intuitive, easier way to do that, but it may increase the tab complexity. So should we transpose or not? That's a question. And by finding the same, here's the good example. The same is the shortest path in this image or in this matrix. We start from here, we go here, go here, go here, go here. By the way, in the rule for this pixel, it allows to go down, go to upper left, and go to bottom left, and then bottom right. So it has three options. And yeah, that gives us the ideas to using the dynamic programming technique and or using a topological sort algorithm. And interestingly for this problem, they are kind of equal because we can think a little bit about topological thought. Basically, we need a sort or the order of the node, in the graph or something like that. So this problem is kind of naturally give us the order of that, just a row by rows. So yeah, that's the reason why the DP solution and the topological sort solution are the same. And yeah, so use this point as the example when we compute. So the meaning, so by using the DP, we need first, what's the meaning of the DPIJ? Is just uh, the 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 shortest path from the source to this pixel or the energy, just the math, the math. And yeah, over here, and it had three ways to reach from the upper row. We can be here and we move here. We can be here and we move here, or we can be here, move here. So yeah, three ways we need to find the minimal ways to do that, and that's the shortest path we want. After we find the same, we save those column number into the array and return the result. That's all we want. So next, we want to remove the seam. Once we found that, we need to remove that, create the new picture object. And basically we need to reduce the width or the height. And still the problem once again is the transpose or not. Transpose is also like easy to do that. We transpose the image, we calling the, for example, we calling the, if we implement the remove vertical first and we are doing the remove horizontal function, we're calling the remove vertical and we transpose the image back. The details are in the FAQ page, so yeah, check that out. So next we can do some optimization, because when we really do the problems, uh, the really annoying part is should we store or save or using the energy as the global object, using the picture as a global object, those kind of stuff. So here, firstly, we can only save the color codes for the picture, instead of using the whole object of the picture, we should just use the color part because that's all we care about. And when we, yeah, pretty much about that. And next, when we doing the energy, we have a lot of duplicate computations. So now we want to store the energy into our two-dimensional arrays. It's just a trade-off time and space. And next, we're going to using get RGB directly instead of a get. The get function is basically just calling the get RGB. So we just directly use get RGB, make it simple and make it efficient. Fourth, lastly, we can use the system.recopy. This is used for the energy function or the color code. When we really want to remove the scene, we can use the system read copy to copy the entire row over there. So yeah. And one really useful tip for this assignment or homework, I've always uh, put this image in my head when implementing the remove seam or find the seam. So yeah, it's really helpful. So yeah, just a big picture. The first one over here, that is the variable holding in the same cover class, and it's holding the picture object and the width, the height. And after we optimize the class or the time complexity, we are using the color instead of a picture, because color is the really important things we need. It's the unique things for these pictures. Others is just the overhead. And next is the energies, because we have so many duplicate computations of the energies in the find the horizontal seam, find the vertical seam. Every time we compute the energy again and again. So yeah, it's waste of time. So we should start them and really compute the really neat parts. And yeah, pretty much about that. So if you have any questions or find any mistakes in my slides, please comment down below. And yeah, I'd like to talk anything about this homework. Enjoy.